Forgive the lighting, one of my lamps died. So video 2 in our how-to welding series that me and my dad filmed. MIG welding. Very common and, to a degree, very simple method of welding. Here is everything you need to know.
An introduction to MIG welding. MIG stands for metal inert gas. It's a welding process that's been around for quite a few years now and is very popular because it's fairly easy to learn and it gives high production rates. So it's favoured by manufacturing all over the world. MIG welding, as I said, is easier to pick up and learn than manual arc welding, so therefore it's become quite popular with the home hobbyist. So we just wanted to cover off on a few points of what parts of the MIG welder do what and how you go about setting a MIG welder to get your first weld down. So in a MIG, it's a constant voltage machine. You set the voltage and then you tune the wire speed to suit the voltage to get the required weld. So the wire feeder is an important part of a MIG welder. You need to have a good reliable wire feeder, and what you're looking for is something with a decent back that can't deflect and move and allow the wire to jump out from the feed rolls. So cast metal is the best type of backing, and there are various types of feed rolls out there. The most common in the entry-level units for home handyman consists of one driven feed roller and an idler wheel with a pressure adjuster on top to set your pressure so that you can ensure the wire feeds through correctly. In the other unit we have here, we'll have a look inside. It has a driven feed roller and a driven idler wheel. They're meshed together by cogs and they both drive, which gives a bit better feed again than the standard feed. There's also two-wheel drive systems where both wheels are driven and both wheels are actually drive rollers, so both V-grooved or both U-grooved. Then there are four-wheel drive systems where all four wheels are meshed together and drive continuously with drive rollers on all four, generally for use with softer materials such as aluminium and bronze and copper. These wires can actually deform if you put too much pressure on them, so it's better to have more feed rolls putting a little bit less pressure on but giving a positive feed. So wire feed rolls come in various types. The most common is a V-groove, which is used for hard wires, so that's your steel, stainless steel, general run-of-the-mill wires. Then there are V-knurled feed rolls, which are generally used with flux cord welding wires, where you need a positive grip on the shell, but you can't put a lot of pressure on because the shell is very thin and it will deform. There's also U-grooved feed rolls. Now, U-grooved are generally for soft wires such as aluminium, where you can't have any deformation of the wire. U-grooved is also used for flux cord welding wires where you've got multiple driven drive rollers. Then there are U-cogged, which are for large diameter flux cord wires, but they're something that the everyday welder is probably not even going to come across. Okay, so if you're using a MIG welder that will run gasless flux cord wire or solid wire, you'll find that you need to change the polarity. So most machines these days have a twist lock connector, like the ones here. These plug in and twist to lock. The problem is if you just plug them straight in and twist, if you're actually getting a spring effect inside the cable, if you let them go, they'll tend to undo themselves. So what you need to do is preload the cable with a twist, then insert, and you'll find that it spins itself shut, so it will lock and stay locked. Very important, if they come undone, you get a loose connection in there, you'll have a hot spot, you can get arcing inside the terminals and it will destroy your machine. So make sure you preload before you put them in so that they stay locked.
So we very briefly just touched on needing to reverse the polarity if your machine is capable of handling flux core gasless wire, and then promptly moved into how to attach the leads properly. We didn't actually explain what reverse polarity is. So the way this machine is set up currently is positive polarity. and that is for handling regular run-of-the-mill gas-shielded MIG wires. So what that is the machine lead is going into the positive feed, and the work return lead is going into the negative feed. What reverse polarity is simply the opposite. So you would remove your work return lead, you would remove your machine lead, and you would simply reverse the polarities. So now the work return lead is going into the positive terminal and the machine lead is going into the negative terminal. The reason we use negative polarity for flux core gasless wire is its own separate video. So if you want to know more about that, hit the like button and we will film a video in the future. But for now, let's get back to the original tutorial.
So the next important item in the MIG welder is the actual gun. This delivers the wire from the wire feeder to the welding pool, and it's made up of quite a few different pieces that you need to know about. So guns come in all different sizes and shapes depending on what amperage the welder has and what type of job you're doing. One of the important things about the gun is the feed liner. So the feed liner runs through the gun from where the gun attaches to the machine up to the contact tip. The liner is designed to guide the wire because you've got a flexible hose that can bend all over the place. So the liner will guide the wire through without letting it tangle or snake inside the gun. Liners generally come in two different types. This one is a steel liner. As you can see, it's like a very tightly bound spring, and that guides the wire through the hose. For some products like aluminium, there are Teflon liners which are very smooth on the inside and have low friction, so it's easier for a softer wire to slide through. And also aluminium can be contaminated by contact with steel, so it's inadvisable to use a steel liner for aluminium. So liners come in different sizes. Generally the smaller guns will handle from 0.6 up to 1 mil, maybe 1.2. Above that you'll need to go to a different liner, and liners go all the way up to 3.2 millimeter for some of the very large wires that are used in heavy industry. The next important piece of your MIG machine is the MIG gun, which is a long hose connected to the welding machine, and most of the welding machines these days have what's called a Euro connector, which is a nice handy connection. It allows you to put the wire into the gun. Also has the contacts here for the trigger and a nozzle which supplies the gas through the gun also. So it's all in one nice handy unit. It's just plugged into the front of the machine and tightened up, and basically you're ready to go. So once you plug that in, you feed the wire through the wire feeder and through the gun. So you'll end up with wire coming out the end of the gun. It's actually best when you feed the wire through to have the nozzle and the contact tip removed, so that there's nothing that catches the wire on its way through. So with the gun you have the handle, you have the switch, the trigger. There's no power in the wire of a welding machine until such time as you pull the trigger, but if you lay the gun down and you lay it on something and hit the trigger, then it will put power in, it will feed wire. If that wire makes contact with something that's connected to the earth return, it will heat up like a big heater element. So if you ever notice that it spewed out a heap of wire, don't touch the wire, it can be extremely hot. Turn off the machine or remove the handgun so that it's not sitting on the trigger, and wait for the wire to cool down before you cut it off. So the wire comes through the handpiece, so does the gas. The gas comes up through the gooseneck to a diffuser. The diffuser spreads the gas flow out so that you get better gas flow through the nozzle. And the contact tip is where the power is put onto the wire. So your power lead is connected up through the gooseneck contact tip is the point where the electricity is actually transferred into the wire. So the contact tip's a very important piece of equipment. It does wear out over time, so if you get an oval shaped hole in there, you can get too much play in the wire, and then you can have arcing inside the tip, which stops the wire, and then the wire will burn up and melt onto the end of the tip, and it's very difficult to then get the tip out and replace it. Contact tips are not overly expensive, so make sure you replace them when they need to. The other thing is the nozzle. The nozzle's important. The nozzles come in different sizes. The different sizes are for different size of weld pool. So the larger the weld pool, the bigger the nozzle, because you need to have a larger area of gas coverage to keep the weld pool protected from the atmosphere. Now, another important tool that you should consider is MIG pliers. The MIG pliers have a large opening in the back. They're spring loaded. That large opening is for holding onto the nozzle. The nozzles get very hot during operation, so when you've got to take them off and clean them, having the MIG pliers is very handy. The reason you take them off and clean them is because they will get spatter up inside the nozzle. So the front of the tool is used for cleaning the nozzle, like so. When you're given a rough clean that way, you can then use the individual sides to get a more thorough clean inside. If you don't clean the spatter out of your nozzle, it can bridge across to the contact tip, and then you can have electricity transferred to the nozzle from the contact tip, in which case your nozzle, if you touch the job, can actually weld itself to the job. So, very important that you clean your nozzle on a regular basis, and MIG pliers just make that job so much easier. The other thing MIG pliers have is a cutter for cutting off the wire to the correct length so that you can start welding. If you've been welding and you've had a bad arc finish, you can get a ball of molten metal on the end of the wire. When that solidifies, it has an oxide coating on it generally, and it's hard to get a good start from that when you start welding again. So it's ideal to just clip that off and have a nice fresh piece of wire to start your welding with. So we said we'd talk about setting a MIG welder, and the way we do that is by setting the voltage to start with. The voltage, if you think of it this way, the voltage is the heat input. So if you want more heat input for a bigger, thicker piece of metal, then you need to turn the voltage up, and then we adjust the wire speed, which controls the amperage, to suit. Being a constant voltage machine, the voltage stays the same, the amperage varies. So what I'm going to show you is what happens when we set the welder up with the wire speed too low for the voltage. Then I'll show you what the wire speed too high for the voltage looks like, and then we can hear what it's like, hopefully, when we get a good weld. So we'll turn our welder on. It's only a thin piece of plate, so we'll start off with about 16 volts. And I'll turn the wire speed way up so it's ridiculous. And once we put on our welding gear, our proper safety equipment, we can start putting the weld down. So we'll start off with the weld speed too high and just see what that sounds like and looks like. But that didn't sound well at all, and we've got a very high lumpy weld that's sitting on top. It's not actually wet into the weld metal, to the parent metal. So that's way too high. Let's turn our amperage down way too low, and we'll see what that sounds like. The wire speed. Sorry, we'll turn the wire speed down below and see what not enough wire for the voltage looks like. Guys?
Yep.
So that's a very thin looking weld that's sitting on top and not at all a successful weld at all. So now we'll adjust the wire speed to somewhere that should be about right, and then we'll take a look at the weld and see what needs adjusting. Eyes. So that's more the sound we're looking for. We have a nice weld, but it's still a little bit lumpy, still a bit high, although it is actually welded into the plate and biting in. So if we want to flatten that weld out and make it look a little better, we can increase the voltage somewhat. We'll try about 17 and 17.7. We'll just adjust the wire speed a little bit to make up for the fact we've increased the voltage. We'll see what this weld looks like. Eyes?
Yep.
So that weld sounded much nicer. It's a wider, flatter weld, and it's wet in and penetrated into the base metal. So that's a much better weld. And that's the kind of sound we're looking for when we're setting the MIG welder.
So that, from start to finish, is everything you need for buying a decent machine, setting it up, and getting ready to lay your first beads of weld. We are more than happy to go more in depth on this subject, but we need to know you guys want it. So leave a like on this video if you're interested, and leave a comment if you have any questions so that we can address them in future videos. That is the second of 2 videos we managed to film while I was up seeing Dad on holiday. If you want more, I need to know that you guys want them, because I'm going to have to go back up to see him. So it is very important that you leave questions, and very important that you get this video watched. So share it with your friends who are interested, and let us know if you thought it was helpful. In the meantime though, I'm going to go weld 100 names into a plate of steel. Alright, bye.